Hello, everyone. Welcome back. We are the A1 team. I'm here with Jessica and Mariah. And this time we're going to be doing angular velocity for our project 3 for dynamics. In this project, we're going to be covering a little bit of rotation about a fixed axis. And so the main focus is to find angular velocity using working energy. Next, please.
For our problem statement, we have determine the angular velocity of a thin circular disk as shown in the diagram varies based on the specific scenario. Each student will have a different set of masses.
Yeah, so this is going to be our pulley using a thin circular disc. As you can see, we have two masses with two different radiuses of 1 and 2. And we're going to just be calculating the angular velocity for each. Next, please. Okay, so right here we have the calculations. As you can see in the top left, we have the diagram. To the right of that, we have the free body diagram. And then I wrote everything that was given. And our known equations for this problem is velocity, which equals to angular velocity times radius. We also have working energy, where T equals 1/2 mv squared plus 1/2 Ig W squared. And the inertia of a thin circular disk given by the textbook that we are using is the inertia is equal to 1/2 mr squared. So under the dashed line, the first thing we had to do was find a inertia for each circular disk using the formula 1/2 mr squared. So we found the two inertias, and then to the right of that, we noticed that since the masses were going to be moving 1 meter down, mass 2 is going to be moving 1 meter down. Mass 1 was going to be moving half positive meter up, which makes sense because mass 2 is a bit heavier. And then we also used the velocity equations, and we saw that v1 is 1 times the angular velocity and v2 is 2 times the angular velocity. And using those were basically all the unknown variables for this problem, the inertia and the velocities. We wanted to convert to to angular velocities. So now using the work and energy equation, we saw that the left side is just equal to 0 because it's starting from rest, which is one of our assumptions. And then, so we basically just have the kinetic and potential energies at the endpoints of these positions. So we have the kinetic energy of mass 1, which is the velocity, the angular velocity, and potential energy m1 gh1, as well energy for mass 2. So plugging in all our unknown variables, we saw that the only missing variable was W. And once we solved for W, it was a positive 1.23 radians per second, which makes sense because this pulley is rotating clockwise. Next, please.
Here were my calculations where my mass 1 was 10 kilograms and my mass 2 was 11 kilograms, but still keeping R1 equals to 1 meter and R2 equals to 2 meters. And after calculating everything, my W equal to 1.21 radians per second.
This is the calculations using my mass 1 that was equal to 3 kilograms and my mass 2 that was equal to 4 kilograms. Using the same radius of R1 equal to 1 and R2 equal to 2, I was able to find the moment of inertia using the two masses And then I was able to determine the angular velocity of the thin circular disk to be 1.31 radians per second. And to sum up our project 3, our group was able to determine the angular velocity of a thin circular disk. Each group member was able to use 2 different masses for the pulley system to get different angular velocity. Hope you enjoyed.